Hello and welcome to the Administering SQL Server 2012 Databases, exam number 70-462, certification course offered by Simplilearn. This is the 6th lesson of the course. In this lesson, you will learn about indexes for tables and understand how to manage them. Let us look at the objectives of this lesson in the next screen. After completing this lesson, you will be able to describe index, list the new types of indexes in SQL Server 2012, explain column store index, describe FILESTREAM, explain file table. This section introduces you to the concept of indexes for columns in a table. You will see why indexes are required, how they are stored, how they work, and some of the index types that are commonly used in SQL Server. The next screen provides an overview of indexes. Indexes are a way to quickly find some data within a table. Consider the case where a table contains, say, millions of records. You wish to quickly write a query so that you only get a particular set of results back. Basically, use a where clause, giving a condition for a column in which the value has to match the one given in the condition. When there is no index, the only way to find the rows that contain that value in the column is by scanning the table. This is a term that signifies that the entire table is traversed from top to bottom to find the row or rows that contain the value. While this might be fast on a table with just a few rows, for a table with thousands or millions of records, this can be extremely slow. This is where indexes play a major role. The index stores the values for each column and a reference to the rows in which they appear. When you try to find a particular value, instead of scanning the entire table, just the index is looked up, and this gives the rows in which the value appears. This is very similar to the way an index works in a book. When you wish to look up a term and find all references to the term within a book, the index at the back of the book lists the page numbers where the term appears. All you need to do is to first look up the index and then the page numbers themselves. While indexes in books are grouped alphabetically for easier search, the index for a column in a table is created as what is known as a B-tree structure, or its variant, the B+ tree structure. This structure basically divides the values in the index into two binary sets that helps you narrow down the value to search for quickly. For instance, if you're looking for the value, say, 18 in a table with 20 rows, the first 10 are in the first branch, and the next 10 in the second. This is further subdivided into the 10 to 15 and 16 to 20 branch, and so on. It basically allows the system to do away with 50% of the possible values in each iteration of the index lookup, narrowing it down to the value you want very quickly. Once the index is found, the system can find the rows where the values appear instantly. Do note that while indexes make queries much faster, they slow down changes, that is, inserts, updates, and deletes to the table. This is because each index attached to the columns of the table must be updated as soon as any change is made. In many scenarios, highly transacted tables are kept without indexes to speed up writes to it. A copy of the table, through many different ways, is kept with all the indexes which are periodically refreshed to allow only queries to the table. Let us look at the different types of indexes in the next screen. There are many types of indexes that are available, and we'll take a look at many of them in this lesson. However, in most cases, you will use only one of the two types of indexes mentioned on this slide. The first is what is known as the clustered index. You can only have one clustered index on a table, and in most cases is automatically created for the primary key. The clustered index has the unique property that the index is what stores the row itself, rather than a reference or pointer to it. Since it's on the primary key, it is certain that each value can only point to a single row. So for the sake of performance, the clustered index stores the row itself so that when you search based on a value on the column, it gets you to the row directly. This is useful since the primary key is used not just in the where clause, but also in joins, and therefore it makes sense to get to the row as quickly as possible. The other type of commonly used index is the non-clustered index. This is one that you can add to any column in the table, and you can even combine columns if they are used together. You can create up to 999 indexes per table, although this is not recommended. This type of index stores the reference to the row or rows as the case may be. You can create indexes in two ways, either using the Create Index statement or using the user interface in SSMS. We'll take a look at doing this in the demo in this section. Let us continue to discuss index types in the next screen. As we mentioned earlier, there are many other types of indexes available. Some of the other ones are listed here and are used in specific scenarios. The spatial index is used in case of using either of the spatial data types, geometry or geography. In both cases, the index allows you to filter on the location or shape-based data. The XML index, as is obvious, works with the XML data type. You can use this to search for values within nodes of a row in a table using xQuery. The computed column index works on columns based on calculations on values from other columns. The unique index works on known unique columns and can make searching for them much faster as well. There are other indexes as well, including some new ones in SQL Server 2012. We will look at these in later sections of this lesson. In this demo, you will see how we can add an index to a table and use it in a query. We start with the Sample AdventureWorks database. Let's expand the product table and see the indexes already defined here. There are 4 indexes already here for different columns. We now decide to create a new index for the color column. Note that we can only create a non-clustered index for now. The clustered option is disabled. This is because the table already has one clustered index on the primary key column. We now create the new index and first give it a name. Next, we need to add the color column to be indexed and save it. Note that the new index now shows up correctly, and we can right-click it to disable, rebuild, or reorganize it. Let's now write a query to use this column and see if the index is used or not. We need to turn on the Execution Plan option to see this and rerun the query. The tab shows us that the new index is used when running the query correctly. Let's now take a look at an important type of index, called the full text index. You will see why it is needed, how it works, and how you can use it in this section. First, let us understand the need for indexing text. Normal, non-clustered indexes are fine for smaller strings, numbers, or dates in tables. But how about when you are using something like varchar max or var binary max type of column? These columns can hold large amounts of text or even complete documents within them, all consisting of thousands upon thousands of words. How do you go about indexing them? The first problem is that normal indexing will index the value of the entire column, not of individual words within them. If you wish to find all rows that contain a specific word within it, there is no easy way of doing so, and even then, it is going to be extremely slow to run. The other problem is that you cannot search for word forms or perform other types of searches. For instance, if you wish to find all rows that contain forms of the word sit, such as sat, seated, or sitting, you cannot do it with a normal index. This is where full text indexing, FTI, and full text search, FTS, come in. FTI includes the technology to index individual words within a column for each row, and FTS allows performing advanced searching using this index. In the next screen, we will learn more about full text indexing. Full text index is a special type of index that works best on specific data types and data. It is usually used on large text columns, such as varchar max, in varchar max, and var binary max, and their older equivalents, text, in text, and image columns. FTI allows indexing of individual words within the column data instead of the entire column in one go. This is done by parsing the data within the column for each row and creating tokens for each word. Common noise words such as or, and, the, etc. are ignored. The tokens for each word are then indexed with the row positions they appear in. If a word appears more than once within a single row, even in that case that only one instance of the row position is maintained. There can only be one FTI per table. Each index is stored in an object called the full text catalog. This object allows you to set parameters on how the indexes within it can work. For instance, in a particular database, you can create many different FTIs, one each for a different table. However, you might not want each index to be rebuilt the same way. There might be some that need to be rebuilt as soon as new data or modified data is saved into it, while others could be done on a schedule. This is where the full text catalogs help. You can add indexes with similar required behavior into individual catalogs. You can then set properties of the catalog for allowing manual, scheduled, or automatic index updates. FTI can not just index text within the column directly, but also text within documents stored within the table in the column. The FTI parser can read and parse text from different document formats, such as Word, Excel, PowerPoint, TXT. You can also add more types it can understand by adding components called iFilters. All you need to do is provide a column with the file extension of the document you have stored in the column you are indexing. FTI automatically takes care of word forms and other grammatical properties. Another capability that you can add is the indexing of synonymous words using a thesaurus. You can also stop FTI from indexing certain words by including them in Stop Words list. Let us discuss full text search in the next screen. The main power of FTI is when used in combination with full text search, or FTS. FTS is the use of two special operators in the where clause of queries, contains and free text. Both are very powerful. Use FTI to get results and have a number of different options. The different ways you can use these two operators are listed below. The first is the simple way. You just give the term to search for, and the operators use FTI to find records that contain that term and return them. The next is called the generational method. The same two operators can return records with not just the given term, but also those containing different word forms of that term. The prefix method enables the term to be at the beginning of the text. The proximity method allows you to specify two terms and the proximity, that is, how close one term should be to the other to be returned. The thesaurus method looks for synonymous words for the terms entered. The weighted method allows entering multiple terms and giving them weightages for being returned in the results. As you can see, there are many different ways that FTI and FTS can work together to give values back. In this demo, you will see how you can set up FTI and use it in an FTS query with data in documents. The first thing to do to create FTI is to set up its full text catalog. All we need to give is the name of the catalog and continue. For this demo, we're selecting the description column of the product description table to use in the FTI. We can create the FTI for the table and follow the wizard. The first thing is to be able to identify a row, so we use a primary key here. Next is the column to index. In this case, description. In the rest of the screens, we keep the defaults and complete the wizard to create the FTI. We can now start writing queries with full text search clauses in them. The Contains clause provides the name of the column and the term to search. In this case, mountain. This returns a bunch of rows with the term in the description column. Even some non-English columns with the term mountain have been returned. We can add simple conditions, such as the one shown. Note the number of rows increase with the OR. More complex conditions, such as proximity of one word to another, can also be used in FTS queries. In this example, we look for the words within 2 words of one another. Note we found 2 rows where this is there, as you can see in the text. On increasing the distance between the words, we get a few more records returned. The next section deals with some of the abilities of SQL Server 2012 for handling indexes and getting data into columns for these indexes. First, Let us learn about column store index. As we talked about earlier in this lesson, an index stores a value of a column and the rows in which that value is available. In most standard data processing scenarios, such as searching and querying, this is what we need. However, in case of other advanced data processing scenarios, for example, in data warehousing and data analysis, this is not what we need. Standard indexing is not optimized for the kind of queries and processing that happened in them. Data warehousing and analysis work on the concept of aggregation of a number of columns at the same time. Due to this, using normal indexing on these will actually slow down the processing. This is why a new type of index was introduced in SQL Server 2012. The column store index is one where the index stores column-based data, not row data, within the index itself. Think of this as a clustered index for columns rather than rows. Column store indexes are also highly compressed, and only columns that can be aggregated, usually numeric values, are stored and read. The rest are ignored within the index. There is one restriction when you use a table with a column store index. You cannot modify any value in the table. That is, you will be unable to use the update statement on that table anymore. This is because of the optimizations done on the way the data is structured within the index. You can continue to add data using insert and query using select. If you do need to update a record, you will need to first drop the column store index, perform the update, and then recreate the index. In the next screen, we will discuss the features of FILESTREAM. The FILESTREAM attribute is not really an index. The FILESTREAM is usually used with a var binary max column, so that files being stored within the column are actually stored into the file system rather than being stored in the table itself. There are many benefits to this approach, such as keeping the database small, synchronized backups, and more. The best part is that you can continue to use FTI with FILESTREAM columns as well. Documents stored on the file system too are indexed and can be searched through SQL. The file types that can be indexed this way are available in the system table called sys.fullTextDocumentTypes. You can extend these by installing ifilters as mentioned earlier. The next screen discusses FILETABLE. SQL Server 2012 utilizes FILETABLE to reduce the complexity that FILESTREAM columns require to add or update documents within it. In the case of FILETABLE, instead of using SQL to add or update files, you create a new file table by simply pointing to a folder on your file system. SQL Server will read and pick up all files within it automatically. Full text indexing will also parse and index the contents of all the files it can understand. The sync is set up to be bidirectional. That is, you can add, update, or delete files either on the file system or in SQL Server, and it will sync to the other side automatically as well as update the FTI. In this demo, you will see how you can define a new column store index. In our AdventureWorks database, the sales order detail table is one on which a lot of data analysis is expected to be performed, especially on the order quantity and unit price columns. Let us update a specific row to see whether the table allows it. As you can see, the value has changed and it works fine. We now create a new column store index for this table. We give it a name and add the two columns to store as columns in the index. While column store indexes are great for performance when doing analysis, they have one drawback. They disallow updates to the table, as you can see. One way around this is to simply disable the index, perform the update, and then re-enable the index again. This demo shows you how you can extend the file types that FTI can parse and index in SQL Server. Let us quickly take a look at the type of files that can be indexed in SQL Server. The full text document types table contains the list of document types registered on the server. Note that while the older .doc, .ppt, and .xls are supported, the newer MS Office formats .docx, .xlsx, and .pptx are not. To enable this support, we need to install the appropriate ifilters. For Office, there are 32 and 64-bit ones available, and we will install the latter. The installation, when complete, installs the ifilters into the operating system. We now need to tell SQL Server to load these ifilters. For this, we use a system stored procedure to reload resources from the OS and then restart the SQL Server instance. Once restarted, we can check whether the new formats are supported. Note that now the new docx, pptx, xlsx, and other newer formats can be indexed by FTI. We will use these in the next demo. This demo shows you the power of FILETABLE and how SQL Server can read and index files in a folder. In this demo, we'll use the Another Test DB database. The first thing to do is to open SQL Server Configuration Manager. We open the Properties dialog for the SQL Server instance and go to the FileStream tab. All options here have to be turned on, as you can see, and then the instance has to be restarted. Once it has restarted, we can close this and return to SSMS. We also need to turn on the FileStream option on the database through its Properties window. We can also do this via a query and set additional parameters too. The next two queries simply set up the place where the file table data will reside on the physical file system and the file groups it belongs to. As you can see, there are no file tables defined as of now. Tables. So we create a new file table called Documents and point it to a directory with the same name. The new file table is now visible, and the new files will be stored in the FILESTREAM folder we defined earlier. To view the folder that contains the files for the table, right-click and explore the directory. Right now it's empty. We can also check this by querying the file table, which returns 0 rows. Let's simply dump a bunch of files in this directory. You can see these 8 files are of the new docx and XLSX format, for which we installed iFilters earlier. On querying the table again, you can see that the files are picked up automatically. We can now enable FTI on these files. First, let's create a full text catalog for this. Next, we define FTI for the table and follow the wizard. Note that we will select the FILESTREAM column to index and provide the type of file using the File Type column, which holds the extension of the file. We modify the query to just show us some relevant columns first. We can now add FTS clauses to the search to find indexed contents within the documents. The documents are fully indexed and searchable through SQL now. Here is a quick recap of what we have learned in this lesson. Index is used to find data within a table. The new types of index in SQL Server 2012 are column store, FILESTREAM, and FILETABLE. The column store index is where the index stores column-based data. The FILESTREAM is usually used with a var binary max column so that the files being stored within the column are actually stored into the file system rather than being stored in the table itself. Using FILETABLE, you can create a new file table by simply pointing to a folder on your file system. SQL Server will read and pick up all files within it automatically. This concludes the lesson, Working with Indexes and Files. The next lesson focuses on maintaining reliability of SQL Server installations.